For the third day of our packet, we're going to take a look at equations of lines. And back in Common Core Algebra 1, you worked a lot with linear modeling and writing the equation of a line. So we're not going to redo how to find or how to write the equation of a line. We're just going to kind of review it a little bit. So quick little review. Slope-intercept form of a line is when you use the equation y equals mx plus b. And in that equation, m is your slope and b is your y-intercept. So the first two examples that we're going to look at, we have in both of those, we have y equals 2x minus 7 and y equals negative 1/2 x plus 3. Both of those are solved for y, so they are in slope-intercept form. And so what we're doing is trying to graph them. So the first one, we have y equals 2x minus 7. So if we think y equals mx plus b, the 2 is going to be our slope, and our y-intercept is going to be negative 7. So to graph this, I know that the graph is going to hit the y-intercept at negative 7. So on the y-axis, I'm going to put a dot at negative 7. And then from there, my slope is 2, and slope is always rise over run, so I'm going to turn it into a fraction, 2 over 1. And then from this negative 7 point, I'm going to travel up 2 units over 1, and up 2 units over 1 again, up 2 units over 1 again, and I'm going to do that a bunch of times. And then I get my line. Once I have enough dots, I can go ahead and connect the line, or connect the dots and get the line. And then you want to make sure that you label it. So that line right there is the line y equals 2x minus 7. And then the other one that we're going to graph is y equals negative 1/2 x plus 3. So again, our slope is the number right in front of the x. So the slope would be a negative 1/2. And our y-intercept is the number hanging out by itself, which in this case is a positive 3. So to graph this one, what I'm going to do is start at 3 on my y-axis. And from there, I'll travel down 1 over 2. So I usually make the negative attach itself to the top number. And so then it tells me to go down 1 unit over 2 units. And I'm just going to keep doing that a few times. And then I can go ahead and draw the line. So the next thing says, what is the solution to the equation 2x minus 7 equals negative 1/2 x plus 3? And then it says why. Well, if the two equations are equal, it means that they basically have something in common. We want to figure out when that equation is equal to that equation. And visually what that means is that the two equations intersect at that point. And so they intersect at the point right there. And the point that I have circled is the solution to that equation. And that would be the point 4, 1. All right, so it's really, really important for you to remember slope-intercept form of a line because it's going to be used a lot in this course. So what we're going to do next is take a look at two lines, y equals x and y equals negative x. And for some strange reason, these are always two lines that cause people difficulty. We did talk a little bit about them back when we were doing reflections. But let's just revisit them again just to make sure that we really, really understand what they are. So what we want to do is pick out the slopes of those two lines. So y equals x and y equals negative x. Really what we have here is y equals 1x and y equals negative 1x. And so the number in front of the x is a positive 1. And over here, y equals negative x, the number in front of the x is a negative 1. And so now if we want to try to graph those two, basically we can come up with some coordinates. So if the y value has to equal the x value, if x is 1, y has to be 1. If x is negative 2, y has to be negative 2. If x is 4, y has to be 4. Whatever x is, y has to equal the same thing. And here, what's happening, y is equal to negative x, our signs are opposite. So our y value is going to have the opposite sign of our x value. So if the x value is 1, the y value is going to be negative 1. If the x value is negative 2, the y value is going to be positive 2. And if the x value is 10, the y value is going to be negative 10. So now if we graph these two things, if we plot the point 1, 1, -2, -2, 4, 4, we end up with 3 points that are on that line. And basically what we looked at with the equations back in, with the equation back when we looked at transformations, this is the line y equals x, starts at 0, 0, and its slope is up 1 over 1. Basically, in this case, goes from corner to corner. So that's y equals positive x. And then y equals negative x is just going to be the opposite. It's going to go from, or through the origin, and it's going to have a slope of -1. And again, you can plot the points if you need them, but recognizing the slope and the y-intercept makes it a little bit easier. So the next thing that we're going to look at on the back is basically, they're not always going to give you the equation of a line in y equals mx plus b form. Sometimes you have to rearrange the equation to get y all by itself. So in this first one, we have y right here. There's no number in front of it, but it's on the same side of the equal sign as the 2x. So we need to take that 2x and move it over to the other side. So I'm going to move the 2x to the other side, and that leaves me with y is equal to -2x plus 7. And now once we have it in y equals mx plus b form, or slope-intercept form, I can easily pick out my slope, and I can easily pick out my y-intercept. With the second one, I'm finding my y. My y is right there, but there's a lot of stuff on that same side. So the first thing I have to do is move the 2x to the other side. And then I have to go through and divide everything by 3. And when I say everything, I mean every single term. So I get y is equal to -2/3 x and then plus 4. And again, once I get it in that form, I can easily pick out my slope, and I can easily pick out the y-intercept. The last one, go ahead and try that one on your own. All right, so exercise number 4, what we're going to do is add what we talked about yesterday and the day before and put that in with our equations. And this is kind of one of those big things that we have to be able to do. We're going to write the equations of lines that are parallel and perpendicular to another line that go through a certain point. So in this case, we have the line S, and we want to write an equation that goes through the point 2, 4. In the first one, we want to draw a line that's parallel to S that goes through the point 2, 4 and write its equation. And then we're going to draw a line perpendicular to S and write its equation. So if lines are parallel, they have the same slope. So the first thing I have to do with line S is find its slope. So I'm going to pick out 2 good points, and it looks like to go from one point to the other here, I'm going down 2 over 4. So the slope of that line is down 2 over 4, which would be -1/2. And so now from this point right here, I can use my slope, which is down 1 over 2, to get a few other points. And then once I have those other points, I can go ahead and draw in the line, and I can come up with its equation. It has a slope of -1/2, and it hits the y-axis at 5. Now, if I want to come up with a line perpendicular that goes through that same point, if the slope of this line is -1/2, the slope of my new line has to be a positive 2 over 1. So from that same starting point, 2, 4, I'm now going to travel up 2 units over 1, and I could also work it backwards, down 2 units and back 1. And what I really want to make sure I do is hit the y-axis. And once I hit the y-axis, I know my y-intercept, and I know my slope. So a line that would be perpendicular to line S that goes through the point 2, 4 would be y equals 2x, and then plus 0 because it hits the y-axis at 0, or really that would be just y equals 2x. All right, and so the last one says, which of the following lines is perpendicular to the one that you're given? So what you have to do here is first come up with the equation in y equals mx plus b form. So you have to clean it up, and then find the slope of this line, and then change it so that it's the negative reciprocal of the line that you see in this equation. And then basically match it up. All right, so see if you can try that one on your own.